Hi Year 10, this is our first lesson looking at coordinate geometry, and the first bit of this topic is just basically looking at a bit of revision. Okay, so first question I want to pose to you is, what is coordinate geometry? Okay, I know for me, when I think of coordinate geometry, well, it's split up into two words, coordinate and geometry. So tell me everything you know about it, make a list or a brainstorm. Okay. What we're looking at particularly this lesson in our review is the gradient of a line. Okay, and we're going to spend a couple of lessons just going over the key things that you should know. Alright, let's have a look at this. So basically, engineers, that build roads or train lines, they need to think about gradient or slope of the track. Okay, another way of thinking about it mathematically is the distance moved vertically being compared with the distance moved horizontally. Okay. We all know about rising slopes. If you've ever been on a D of E hike, or you just like hiking, or you've climbed a mountain, there is going to be a tough slope there. Okay, so you can see in this little picture here that the rise is 5 and the run is 1. So the slope or the steepness of the slope is 5, and that's basically what the gradient is. Okay, same with this car. They're going up a road where basically it's 1 up and 5 across. Okay, the rise is 1, the run is 5. Okay, so tell me what you think we mean by gradient. And I just kind of told you that it's the slope or steepness of a line or something. And what is the gradient of a line? Well, I just answered that as well. So in gradient, we're talking about slope or steepness. Gradient of a line, well, it's just the slope or steepness of a line. Okay, and think about all the things that the gradient tells us when you answer these questions. For different types of gradients, well, you can have, they're listed here, so you just need to write them down. So negative, positive, we can also have 0, or we can have also undefined. Okay, so write down those 4 things. How do we calculate the gradient of a line? Okay, there are lots of different ways to calculate gradient, but basically it's really important for you to remember that the gradient is thinking about a change in the x and the change in the y values. Okay, so if I've got a right angle triangle, one method is, if you've got a line, one method is to draw a right angle triangle. Okay, and figure out the change in y, which is the rise, over the change in x, which is the run. Okay, so this is the rise here, and this is the run along the bottom. Okay, so one way of figuring out the gradient is using this, figuring out the rise over the run when you've got a plane, a number plane, which in coordinate geometry we work with a lot. You can make a right angle triangle. Another issue we have is sometimes they just give you 2 points, find the gradient of 2, 3 and 4, 6. Okay, what's the gradient? Remember, we represent gradient by little m. Well, the gradient formula is helpful for that. Okay, and here's an explained diagram of that. I showed you this last year, but let's have a look at it again. So to get the slope of a line or gradient, little m, you take the change in y values over the change in x values. Okay, so you need to write this down, write down the formula. How do we figure that out? Well, if you've got a point here, x1 and x2, and then you've got 2 points here, y1 and y2, then this is the point x1, y1, this is the point x2, y2, that should say, that's x2, y1 as well. And we've got x2, y2 up here. Okay. In fact, we're only really thinking about these 2 points here. We don't really need this point here, but we need it to figure out the right angle triangle. Okay, so what we're going to be looking at is these 2 key points, x1, y1 and x2, y2. To get the difference in the y values, well, we've got 2 things. We've got this y2 number here, whatever that is, in line with the y slope, and this y1 number in line with the y here. Okay, so y2 minus y1 is the rise, and that's why this is here. Okay, so that is the rise, vertical rise. We then have x2 minus x1 to get the distance here. Okay, and this is the horizontal run. And when you label your points x1, y1, x2, y2. You don't have to plot them and make a triangle and figure it out. You can just use the formula and plug it in. Okay, and we've done that a lot last year. The other thing that I introduced you to last year was also the gradient given the angle at the x-axis. Okay, so to get the gradient of a straight line, we can use something special in trigonometry. Tan theta is the same as the gradient only when theta is the angle the line makes with the x-axis in the positive direction. That is really important. Okay, so here's some diagrams. So positive direction with the x-axis every time, and opposite over adjacent is the ratio for tan. Okay, so important things to remember: for an acute angle, tan theta will be bigger than 0, and for obtuse it will be less than. Okay, let's go through a few quick examples. I'm not going to do them all with you here, but we will go through any that you didn't understand in class. Alright, so first thing in this one, create a right angle triangle. So I'm going to go down here. Oops, no, it's too far. So create a right angle triangle. So I'm going to go down here and make a right angle triangle from these 2 points. There's my right angle. Now my gradient is rise over run. Vertical rise over horizontal 1. My rise here is 1, and my run is 1, 2, 3, 4 spaces, so my gradient is a quarter. I then need to think about the 4 types of gradients: positive, negative, 0, undefined. This is leaning to the right, so it's positive. Okay, so I can leave my answer like that. You have a go at this one. Okay, some interesting problems. The line joining KL has a gradient of -1. Find the value of B. So I'm going to use the same process as I would x1, y1, x2, y2. I know that m is -1. Okay, here's my formula. M equals y2 minus y1 over x2 minus x1. So I have y2 minus y1. So I'm going to have, therefore, 7 minus -3, which is +3, over 2 minus 2b equals -1. Okay, and I need to solve this equation now. So I'm going to have 10 equals, now it's -1 times all of this here. So I'm going to get -2 plus 2b and solve this equation for b. Okay, so I'm going to have 2b is 12, so b is 6. Okay, so just kind of extrapolating to get out what we want. Okay, are the points R, S, and T collinear? What does collinear mean? Collinear means that the lines, it's asking you if these lines, these points all lie on the same line. Okay, so it means points, so more than 2 points lying on the same line. How would you prove that? Okay, it's going to have something to do with gradient. I want you to have a go at that yourself. Have a good think. Okay, let's have a look at these two. Find the gradient of a line that makes an angle of 45 degrees with the positive x-axis. Really easy key definition telling you you're going to need to use m equals tan theta. So it's going to be tan 45 degrees, and when you type that into your calculator, so you're going to go tan of 45 degrees equals, you should get 1. Okay, so the gradient here is 1. And question 5, this time it's an obtuse angle, which tells me if I go back up here to my definitions, for obtuse angles, tan theta will be less than 0. So in here I'm going to have m equals tan theta, and I know what theta is here. It's 135 degrees. Again, you've got to type that into your calculator. Oh, so sorry, this is a bit of a different question. So let me just go back. I didn't read the question properly. Always important to read the question properly. It says if a line makes an angle of 135 degrees, find the angle theta makes with the positive x-axis if the line has a gradient of 20. Okay, so this time there's a bit of this information here. Not sure how helpful that is. Okay, let's have a think. So it's telling us the gradient's 20 and they want us to find theta. So let me just switch this around the other way. Because I'm finding an angle, I'm gonna need to find the inverse, which means pressing shift in my calculator. So I'm gonna go shift tan of 20 in brackets and get that as in degrees, minutes and seconds. It doesn't tell me how to leave my answer, so I'm just going to leave it to the nearest degree, and I got 87 degrees. Okay, so that's theta. Okay, so that just kind of puts you up to speed with finding the gradient of a line and what it is, and different things that we've gone over last year. Write a summary of what you learned, any questions, including a higher order thinking question, and bring the sheet completed next lesson. I'll see you in class, guys.